Hi, everyone. My name is Caleb Cordry, and I am a software engineer on the AMP team. And today we're going to be talking, or I'm going to be talking about making AMPHTML ads easier. Quick caveat, sometimes I say creative instead of ad. I'm going to try to just say ad, but they mean the same thing for those of you who aren't familiar with ads. So, start. AMP-HTML ads are given special treatment on AMP pages. So some of you might not know this, but basically because of the properties that are guaranteed by the AMP-HTML format, we'll go in specifics about what this actually means a little bit later, but they are in fact given special treatment on AMP pages. Some ad networks even go as far as to give these ads using this format special treatment on non-AMP pages. We'll talk a little bit about that, but it's not really the focus of this talk. So what are the special treatments that these ads are given? Again, we'll talk about this more in detail, but it's a high-level overview here. There's a few things. The first is this concept that we on the AMP team call fast fetch. What this means is that ad requests for all ad slots using for ad networks using the AMP-HTML ad format are able to make their ad requests very early in the page lifecycle, and we call that fast fetch. The second is this concept called friendly iframe embed, or we abbreviate it as FIE sometimes. What this means basically is that we render these ads in a same domain iframe. A lot of you are probably aware that same domain iframes, just from browser implementation standpoint, are actually much cheaper. But there's also a few AMP-specific things going on here where that in the same domain iframe, we can actually share the AMP runtime between the ad and the parent page itself. And last is this concept of layout priority, which is also an AMP-specific thing. Excuse me. What this means is we in AMP are kind of in control of the whole, like, when elements are rendered. And because we know of the guarantees of the AMP ad format, we know that we can allow these things to render sooner and they won't be competing with the parent page for resources. Cool, so knowing that, unfortunately the AMP-HTML ad format is not widely used outside of a few large ad networks. And there's one big reason for this that I'm gonna really hammer over this talk, but it's complexity. The way we designed it works well, but it's hard for ad networks to implement. Cloudflare actually used to offer this sort of AMP-HTML ads as a service, but unfortunately it was recently deprecated. And so we're gonna try to make it easier. So if we take a quick step back, I know we're on the AMP chat, but some of you are probably familiar with most of this, but I'm just gonna give a quick overview of like sort of some of the guarantees that come along with AMP or inherent in the format. Right, and so I just stole this straight from amp.dev. But it's a lot of the sort of enforcements that AMP is able to guarantee. Things like no arbitrary JS. I'm not gonna read them all, but all elements must be statically sized, so we don't have things like page jank. And we try to do things like yield to the user as much as possible. I think you can sort of take all these guarantees and lump them into three main buckets. The first one I'm gonna say is performance. Second is user experience. And the third is security. And I think these are really like three of the main pillars of AMP. Okay, so why do we care about this? A big reason at Google that we like the AMP format so much is that with these guarantees, we can safely embed these pages in different contexts. I have the search results pictured here, like just Google search in the viewer. And basically, we know that with the AMP guarantees that if we render these into like google.com, they're not going to do bad things, even though they may be from domains that we don't know. Like they're just from random domains, but if they're using our format, we know we have a high level of certainty that they're going to be safe and performant and have good UX and this sort of thing. And so how do we actually accomplish this? This format is designed to be statically verifiable. So what this means is we have also this concept of an AMP validator, which basically just looks at the document and does some parsing, and it can validate it statically and say like, okay, here's the AMP format, and knowing so, we know that these sort of guarantees are in place. Cool. So this brings us back to the ads. Some of you must be might be a little less familiar with ads, so I'll just give a quick overview here of those as well. But basically, these are just ads that are built using the AMP format. So here's a quick example of a very simple AMP HTML ad. It's mostly like an AMP page. There's a few small differences. First, instead of lightning bolt, you have this lightning bolt for ads, or AMP for ads signifier. Second, we have a separate runtime for AMP HTML ads. This is what we actually call our in a box runtime. And in a box means AMP HTML ads served to non-AMP pages, which again, we're not going to focus on too much. For AMP ads served to AMP pages, we actually just ignore this, but exists so they can lay out on non-AMP pages. The boilerplate's slightly different. It's actually much simpler for AMP HTML ads. And then the custom elements are all the same. There's no, I mean, they're basically, yeah, they're shared between AMP and AMP HTML ads. With one big caveat is that we have a allow list of, or deny list as it may be, of certain elements, so that like only certain elements are allowed in AMP HTML ads. Specifically like AMP iframe, for instance, we don't want to be inside the ad itself. Cool. So what's the goal of these AMP HTML ads? It's basically the same. We want good performance, we want good user experience, and we want the security guarantees, like same as the AMP format. And this allows us to do a very similar thing to like whereas AMP pages can be embedded onto the search page, these AMP HTML ads can be embedded into AMP pages without us being concerned that they're going to do like bad things like Bitcoin mining on the parent page. Cool. So how are we able to do this? For normal ads, we had this sort of like validation upon caching mechanism. This actually doesn't exist for AMP HTML ads. It's a little bit trickier. This is because ad networks actually generate a lot of these creatives or ads on the fly. You can imagine an ad network has like some templates and the advertiser just uploads like an image and some text. And the ad network doesn't want to like cache all these sort of like near infinite permutations. So there's like no real caching there. So how are we doing it? Well, right now, so this is like the current state. We have this cryptographic signature that is returned in the ad response from the ad server. This is just a header. It's a AMP fast fetch signature header. And what it basically is a checksum that ensures that what the ad server has sent is the same thing that comes to the runtime. So like the ad has not been altered in any way. So we have that. The second thing is this giant AMP ad metadata object that actually gets added to the inside the body of every creative. And it's big and it's complicated. And one of the things like in tandem with the previous slide is like you have to transform this, add this object, and then sort of do the checksum afterwards. And it's complicated. Just keep saying it's complicated, I guess. So yeah, this metadata object, we don't have to worry too much about what's inside of it, but it basically signifies a bunch of things to the runtime. I'll go quickly through it. Like we have these indices here. This actually indicates like where the body is of the creative. So we can like slice it out. A lot of time, or through this process, we're just treating this response as like a text string. And so we're literally just like slicing out the parts we need. We have these other attributes that say like, oh, these are the extensions that are inside the ad. So we can sort of preload them and install the extensions as we need to. We actually install the extensions to the parent page. This is how we like share the two between the ad and the parent page. Similarly, we have these images that might be inside the creative. We also can preload these, just easier for us to extract them from this object. This last bit is a more string offsets, basically. You know, we're just calling string.slice, but these let us extract the any JSON that may exist, so we can further like you know, parse them or use these objects to do things. Cool. Right. So what does the life cycle of this AMP HTML ad and its current state really look like? We have this fetch request. As I mentioned, this is what we call our fast fetch, where we fetch it early in the page lifecycle. Then we use the header that I mentioned a couple slides ago to verify the cryptographic signature. That all looks good. We extract the metadata. As I mentioned, this is just a text. It's literally just a regex to like find that object in the creative body. We then parse that. We use it to install the extensions, the fonts, the images. We create a same domain iframe. First, we just do like sort of a stub of an iframe with nothing in it. Then we install all the extensions from the metadata object to the parent page. Because the same domain, they can like sort of share these. And lastly, we render it using the source doc attribute on the iframe, which allows us to take the body we've sliced out using those like indices and just transfer it over to the body of the iframe, which actually displays it on the page. Okay. So what I'm trying to say with all these few slides is this is difficult. It's hard for ad networks to do this. It's hard for them to do the cryptographic signature. It's hard for them to do the transformations and then sign it appropriately. It's hard for them to give the right like indices of where like the body is, that sort of thing. And so sort of the genesis of this idea and this talk is the idea is like, what if we could take or enforce these sort of same guarantees, again, their performance, UX, security, without all this complexity. And so how are we going to do this? Magic. No, not magic. I just like this GIF. How are we really going to do it? Built-in browser security features, mostly. Fortunately, there's no cool GIF for this. But we're going to be leaning heavily on two things. One, the first is this content security policy. For those of you who don't know, this is can either be a header or a meta tag. We're gonna lean on the meta tag part of it. I have the definition here. This is from Wikipedia. But what this allows us to do is basically explicitly allow or deny certain domains for things. So like if you only want your style sheets to come from certain example.com, you can do that by explicitly setting that property. Second is the iframe sandbox attribute. Here's the definition from NDN. But what this does, what we're using it for mostly is allowing the iframe to, because this is an ad, to sort of navigate to like a landing page. This is important for ads because you want people to be able to buy their shoes or whatever, while explicitly not allowing JavaScript to run in the iframe itself. Cool, and then also we have some lightweight client-side validation that I'll go into in a little bit more detail. And we're going to use some of the browser APIs as sort of streaming APIs as an added bonus here. Cool, yeah, and just some links to CSP and Sandbox if you want to learn more about them. Okay, so this is what our actual implementation will be looking like. So on the left here, we have the Sandbox properties we will set. As I sort of mentioned, these are mostly to allow the iframe to, like the ad, to like navigate to its landing page. If the user clicks on it, you can go to coca-cola.com or whatever. And explicitly not allowing scripts in here, right? And then on the right side, this is when we're near ready to render the actual creative, what we'll do is we'll create sort of this skeleton document that includes this content security policy meta tag, CSP tag. And what this does is it allows like images and videos and things from any domain, while explicitly disallowing things like scripts from arbitrary domains. And then like you may notice this style source thing with the allow list there. What that's about is these are like our font providers that we think it's okay to load fonts from. Cool, and then as far as like the actual JavaScript, this is sort of a simplified version of what we're doing. I just wanted to show some of the APIs that I thought were neat that we're using to accomplish this. The first is this, and again, this is just a browser thing, create HTML document. What this actually does is creates a in-memory document. And this is neat because it allows us to sort of pipe our ad response into it. But it's all in memory. So like it gives you the benefits of the DOM. You can use DOM operations. You can use like query selector and stuff on it, and it will all just like parse for you automatically. But it's all in memory, so it's not actually affecting the real DOM itself. The second part here is another browser API we're reading, this body.getReader, which actually gives us a stream of readable bytes. So we're no longer waiting for like the whole response to complete before we do like our validation and parsing. We're doing it in chunks now. So this reader, yeah, we get the reader, and then you can call read on it. This is a simplified version, but then we decode it to text and we write it into our in-memory document. This third section here is a sort of a transforming stream. It's not actually a transforming stream because these are not widely supported yet, but it's sort of functionally serving the same results. And this is what this does is it takes each chunk that's received in this in-memory document, and each time it receives a chunk, it says like, hey, is my body here yet? Is my body here yet? Is my body here yet? If so, if the body is available, then we know that the head is fully formed. And at that point, we can do our client-side validation. So we just resolve a promise that says like, hey, our head's ready. Go ahead and you can do your validation now. And that's what's happening here at this last part. We sort of just call this wait for head method. And then we know when that promise is received, we have the head and we can do our validation. And then the last chunk here is about, we wait for that like head validation to complete, as well as I'm calling ready to render, which sort of catch all for all our other signals. Like we may not want to render until like the ad is close enough to viewport that we think it should be laid out. And so we just wait for both those signals. And once they're done, we can then write our sort of sanitized head to the document, like the skeleton document I mentioned earlier. We can then write our sanitized head into it, and as well as one time sort of transferring anything that may exist in the body in this in-memory document over to the actual iframe to be displayed on the page. And then we sort of redirect the stream, which may or may not be finished at this point, to just sort of pipe directly into the iframe on the page. So like as more content comes, it should just display on the screen. Okay, cool. That's a lot, but hopefully you can review the slides too if you're interested, and I'm happy to answer questions. What are we actually doing on this client-side validation? So these are sort of another way we're enforcing our AMP guarantees here. What's happening? Okay, yeah, there we go. So what we've determined, some of this is sort of just in defense in depth, but like we're just trying to like, again, sanitize and validate the best we can within our head element here, while like, including the functionality and sort of omitting the things we don't want. So if we see things, when we get this like wait for head promise to resolve, we sort of just walk all the elements in the head. And remember, this all in memory at this point. So we see anything like title, meta, fonts, JSON, we need all this stuff. So we will just copy it over to the iframe, the actual iframe that's rendered on the page. But as we're doing that, if we see like a script tag that's not from the AMP CDN, we can just ignore it, right? And it just stays in the memory document, which eventually gets cleaned up later, and we don't have to worry about it. Similarly, like we see AMP elements, at this point we're walking the head, we can then preload them and install them. And also we have our allow list here where we can check like, is this element allowed in this AMPHTML Ads format? So install it. If not, don't. And then finally, yeah, we can also take any AMP custom styles, like, right? So styles have to be in this AMP custom tag, and keyframes that may exist in the head. We just copy those over because those are good. But also, if we see any other styles, we ignore those. A lot of this actually is handled by the CSP and sandbox stuff I mentioned earlier, like the JavaScript part, but it's just sort of like a defense in depth. Second layer of protection here, just in case. Cool. So that's basically it. Yeah, the client-side validation, the CSP, and the sandbox are basically like the three main things that we're going to do for this design here. But we can talk a little bit about sort of the trade-offs under this new model that we're making. First, like guarantee we had before, and how we're going to enforce it now. So first, no arbitrary JavaScript. As I mentioned, this is sort of handled by the sandbox attribute, as well as our defense in depth. When we walk the head, we just don't install random scripts. Things like no child frames, applets, objects, etc. This is handled by CSP. We just do, source none, and the browser will just reject these things for us. Only selected AMP elements. This is sort of our head validation, client-side validation. When we see these things that we don't want, we can just not install them. Native elements, these things will just work. This is a little different than our current model. We're actually going to wind up changing the spec a little bit here. But the idea with this new design is that you may no longer have to use AMP image in your creative. You can actually just use image elements. We've talked a lot about this, and we think it's a good trade-off to make. It'll make it a lot simpler for advertisers and ad networks that are generating these things. And we think with all the other like enforcements, we can still guarantee our like performance, UX, and security. No external style sheets. Again, this is just handled by CSP, source none. In our case, it's actually we whitelist or allow list the font providers. But other than that, not allowed. Things like CSS limits. This is in our sort of client-side validation. We can actually just check. I mean, this is still up for discussion a little bit, but if we want to, the mechanism's there where we can say like, oh, how many bytes are in this like tag? And if it's over the limit, we can just reject or fall back. Resource scheduling. So this one's a little different than it was before as well. Because we're going to allow things like images, we may lose a little control over specific elements inside the ad, inside the iframe. But we think this is an okay trade-off to make because the iframe as a whole will still be scheduled by the AMP runtime. So instead of like each piece of the iframe, we're sort of like moving a level up to where the iframe itself will be scheduled and should be handled at that level. Also things like static layouts, similarly, we're gonna handle this at the iframe level. Like the parent page should not jank around or anything because the iframe will be statically sized, but the components themselves may be a little different. And there's also things like video autoplay, like how are we gonna handle this if we allow things like video elements. The answer we've determined here is that browsers have gotten a lot better about like things like autoplay, and we're just going to try to let browsers, like, we're going to try to let this logic happen at the browser level and hope that they're doing the right thing. Cool. And so the end result, hopefully, that we get from all of this in the goal we're trying to accomplish is almost all of the same benefits with this complicated system, but we get it with a lot less complexity. And that's sort of the whole idea here. And there's a few additional benefits as well. That come along with this new model. One, all ad networks will now get the fast fetch treatment. Previously, again, this was only allowed for ad networks that had sort of implemented this AMPHTML ad serving. But now we think under this new model, we can open it up to a much wider range of ad networks. Second, less complexity hopefully will lead to increased ad network adoption. So we're hoping just like the ease of actually serving these ads will make it, because it's easier, it will lead to increased adoption. That's the idea. Right, and then this is not a breaking change. So all existing AMPHTML ad networks that have all the signing and the metadata object and everything, they'll just work. They don't need to make any changes if they don't want to. It's more just like a superset that's allowed now. Cool, and then lastly, this is more about the advertiser side. This is like, the idea is that creatives or ads not using JS can just add the lightning bolts and render as AMPHTML ads. What I mean here is that like, if you have just a simple image creative that won't get like broken by our CSP and sandbox policies, if you give us the lightning bolt, like we'll have a fallback case, but if you give us the lightning bolt, we will say, okay, we will try to render this as an AMPHTML ad. So in theory, these simple image ads can say, okay, try to render this as AMP, and we should be able to do it successfully. And hopefully that will make it easier for advertisers or ad networks that are sort of generating these creatives on the fly. Cool. Yeah, and that's pretty much it. This is still a work in progress. We're actually just in the middle of implementation here. I've linked this GitHub issue. If you want to follow along or comment, concerns, questions, sort of thing, that'd be a good place to sort of voice them. And the second link here is actually the doc that we wrote. It's a lot of the same information that's actually in this talk, but explores some things in a little more detail if you want to check that out. And that's all.